Hey guys, welcome back for another session of SAT Math Prep. Today's question is a word problem, and it says, on a square game board that is divided into n rows of n squares each, k of these squares lies along the boundary of the game board. Which of the following is a possible value for k? So basically we're given a square that is n by n. Hold on. Let me draw a diagram for you guys. Okay. We're going to have this beautiful game board divided into n rows of n squares. So I'm just going to create a random amount of rows. How many was that? 1, 2, 3, 4, 5, 6, 7, 8. So that is n. It's not actually 8 because we don't. It's not 8 because we don't know what n is. They're just giving us 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's n by n squared. And then k of these squares lies along the boundary of the game board. So all the squares that I'm now filling in stands for the number of squares that are along the boundary and thus represented by k. Okay, so now we have to find the relationship between k and n, and let's think about this. So in order to account for all the squares along the boundary but not double count any, we're going to have to think about this because we don't want to be, well, like say if we were going to say it's 4 times n, that wouldn't be right because we'd be double counting the corners. So to be extra careful, we don't want to double count the corners. Let's just set off the corners for now. I'm just going to circle them. Set off the corners. So if we were just going to count this row minus corners, it'd be n minus 2, right? Because each row has 2 corners, but we're not counting them for now. So, except there are 4 sides, so we're going to say this is 4 times the quantity of n minus 2. Alright, so we have all 4 sides minus corners. Now we can add in the corners, and we did not double count anything. Okay, now let's simplify this expression. 4n minus 8 plus 4 is just going to give us 4n minus 4. And notice that this is just 4 times quantity of n minus 1. Now if you notice this earlier, say we just take one side, everything minus 1 corner. So for each row, let's say it would just be this section here. That is n minus 1. And then we can do that to each side without double counting or missing any square. So if you notice that early on, great. It's just 4 times the quantity of n minus 1, and that'll give us the boundary squares. Okay, so now that we know that 4 times the quantity n minus 1 stands for k, we need to find which of these values is a possible value. So that means whatever k is, it has to be divisible by 4. And if it isn't, it's going to give us a decimal, which is not, you can't have part of a square because that is not possible. Let's start with option A, 10. 10 is not divisible by 4, so it is not a possible value for k. And let's just check it real quick. Let's say that k was 10. 10 divided by 4 is going to give us n minus 1 equals 2.5. And then n would equal 3.5. You can't have a game board that is 3.5 by 3.5 squares. That doesn't make sense. Alright, so we see how important it is for k to be divisible by 4. Alright, moving on. B is not divisible by 4, 25 is not, so that is out. Same with C, and same with D. And we're left with E, and that is the right answer, and let's just double check. So 4 quantity of n minus 1 equals 52, and it is indeed divisible by 4. We're going to get 13, and n would equal 14 in this case. Not that it matters, but I'm just showing you that we actually get an integer. And in all the other cases, we would not have gotten an integer. So E is the right answer. Thank you for watching. Please join us again next time.